In this video, we are going to do a couple examples of analyzing compound interest problems in which we're going to be solving for the rate. Okay, the interest rate is there. The first thing I want to point out is that does not require logarithms. So in this video, we won't need logarithms. So you'll see what I mean, but the short answer to, or the short way to see that is that r is not in the exponent. You only need logs when the variable is in the exponent. So let's take a look at this problem and see if we can get a good answer here. So this says Peyton is going to invest $4,400 and leave it in an account for 5 years. Assuming the interest is compounded annually, what interest rate to the nearest tenth of a percent would be required in order for Peyton to end up with $520? So I'm going to underline the question again. What interest rate to the nearest tenth of a percent? So again, we're trying to find R in this equation. We won't know what that is, which means we'll know what everything else is. Everything else in that equation will turn into a number. So let's see here. It says he's going to invest $4,400. This is an initial amount. That's the principal. He's going to leave it in the account for 5 years. That is a time value. That is how much time it will be in the account. So we know T. Assuming the interest rate is compounded annually, if something is compounded annually, that tells us that our n is a 1. Okay, now that takes care of the principal rather, the n and the t. I told you that we're solving for the r value, which means we still need that a to turn into a number, and that is, you'll have to read to the very end. It says what interest rate would be required for him to end up with $520. That is our a, or our a of t if you use function notation. So let's write this all down. Our a is $520. Our principal is $440. 1 plus, we don't know the interest rate, divided by n, which is 1, to the 1 times 5. So our goal is to solve this for our r. Okay, we have to undo everything that's happening to r here. The last thing that happens in this equation is that multiplication by 4,400. Whoops. That multiplication by 4,400. So we have to divide. I mean, not 4,400, 440. Okay, so that brings me to 520 divided by 440 equals, now notice r over 1 is, anything divided by 1 is just itself. So I can write this as 1 plus r. 5 times 1 will just turn into a 5. So now I have to undo raising something to the 5th power, and I do that by raising it to the 1/5. So I have to raise both sides of this equation to the 1/5. That causes the right side to become 1 plus r. Okay, now you can turn that left side into a decimal right now. I like to do that at the very end. So I'm just going to be completely comfortable with writing this as 520 over 440 to the 1/5. I'm just going to leave it like that. Again, our goal is to solve for our r value. We are almost there. It's just I have a 1 added to it, so I got to undo that and subtract 1. Okay, so if we were to write our answer, it would be 520 over 440 to the 1/5 minus 1. That's our r value. Whatever that is in the calculator is what we're going to jot down. And then we're just going to remember to round to the nearest tenth of a percent. So we'll need to focus on that. But let's get to the calculator first. So 520 divided by 440. So I'm going to start a fraction. In fact, I'm going to put parentheses right away. Because look, I've got 520 over 440. I've got to raise that to the 1/5. 520 divided by 440 I'm going to exponentiate that to the 1 divided by 5. Okay, I go down and I minus 1 from that. So I've got an answer here of 0.033975. So I jotted down more than we're going to need. And the reason I did that is because we need to do two things right now. It says to answer the question by finding the interest rate to the nearest tenth of a percent. So let's turn this into a percent first. So I do that by moving the decimal 2 spots to the right so that it becomes 3.3975%. But the nearest tenth of a percent would mean that I go to the tenths place, I examine the number to the right of it. That's a 9, which tells me I need to round that 3 to a 4. So my final answer is 3.4%. Okay, let's try another one involving the interest rate that might have maybe one other extra step I'm going to need to focus on. Okay, this says Layla's going to invest $5,200 and leave it in an account for 15 years. So notice we know that that's our P, our principal. Leave it in the account for 15 years, that's T. Assuming the interest is compounded monthly, if something is compounded monthly, that tells us that our N in the equation is a 12. What interest rate, so we don't know this, that's our R, to the nearest tenth of a percent, so we're not going to be expected to know what R is, would be required in order for Layla to end up with $13,800. That is a future value. So we plug these numbers into our equation above. 13,800 is equal to the principal times 1 plus the R value we don't know, so that stays a variable. My N is a 12, to the 12 times T, which is 15. And our goal is to solve this for R. Okay, so the first thing we got to do is undo all the things happening to R. So the last thing that would happen to this expression is to multiply by 5,200. So we have to undo that first. Okay, and a lot of these money problems, just as a little trick, a lot of these money problems end with a couple zeros. Don't forget that this division is pretty easy, right? You can just divide both of those sides, the numerator and denominator, by 100. That might just, I don't know, a few fewer button pushes to use. So why don't we do that? So now I've got 138 divided by 52 is equal to 1 plus R over 12. Okay. Now I got to do 12 times 15. I want to do that to make sure to see what that is as an actual number. So 12 times 15, let's clear this out. 12 times 15, and I get 180. Okay, so that's 180. I've got to undo raising to the 180. So I do that by raising to the 1 divided by 180. Okay, and that allows me to cancel those. Again, I'm going to leave this as 138 over 52 to the 1 divided by 180. And now I've got that equal to 1 plus R over 12. Okay, now I've got two things happening to R. It's being divided by 12, and then you're adding 1 to that. I got to undo those in reverse order, so I need to minus 1 from both sides. So I get 138 over 52 to the 1 over 180 minus 1 is equal to r over 12. Okay, and then the last thing I got to undo is that division by 12. So I got to times by 12. I'm going to put big parentheses to make sure I times my whole answer by 12. Okay, so my answer is r is equal to this thing up here. So to save on just having to rewrite it, let's just note we're going to go put that in the Desmos exactly as it's written. So it's 12. I'm going to use parentheses. I'm going to start new parentheses, 138 over 52. So still inside another set of parentheses with a fraction. 138 divided by 52. I need to exponentiate that to the 1 over 80. So I go up here. 1 over 180. Okay, and then I need to minus 1 from that. Gotta make sure I get down here, right? Minus 1. And I get 0.0652. So I'm going to write more than I'm probably going to need. 0.06524. I think that should be good enough. Okay, so two things now. We're trying to get our answer to the nearest tenth of a percent. So we turn this to a percent. So I'm going to move the decimal spot 2 spots. So that's 6.524%. And then I do the rounding. The rounding said to round to the nearest tenth of a percent. So this is the tenths place. That number is 4 or less. So it stays at 6.5%. And we are done. So that is an example of solving for the interest rate. Okay, so those two examples solving for the interest rate. Notice we did not need logs. We needed to know how to essentially undo exponentiation. That's this step here. Kind of the key step was probably the one that's you can see right here. Okay, in that problem, and then in the one before, it was up here. Okay, exponentiating to the 1 over 5. Anyways, give those a shot, and hopefully it goes well.